Alright guys, and welcome back. Today we're going to continue with our geometry sections, and we're going to be talking about perimeter, area, and surface area today. So we're going to be talking about both two-dimensional and three-dimensional figures. We're going to move through this really quickly, but again, this should all be review for you at this point. The first thing I want to talk about is perimeter. Perimeter is simply the distance around the outside of a figure. So how do we find perimeter? We simply add all the sides together. So if I want to know the perimeter of this hexagon, I'm simply going to add all the sides. So I have 8 plus 8 plus 7 plus 8 plus 8 plus 7. And when I add all of these things together, I end up with the perimeter being 46 centimeters. And you want to make it a habit of being sure to include units on each one of your answers when we're talking about perimeter and then area and surface area and eventually volume. You want to make sure that you have the units included. Circumference is just a little bit different because circles are a little bit different. Circles have to incorporate that number pi, which we have learned to approximate. Pi is approximately 3.14. Okay? Your calculator has a pi key on it so that if you did not want to do approximations, you could always hit the pi key. But for all the calculations I'll do today, I'm going to go ahead and round pi to 3.14. So circumference is what we call the distance around the outside of a circle. And we can find that two ways. We can either do 2 times pi times the radius, r, or we can do pi times the diameter. The 2 and the r could go together to make one diameter. Since I'm given the radius here in this circle, I would use the 2 pi r formula. So I'm going to have 2 times pi times my radius of 2.5. Again, if I approximate pi as 3.14, I end up with the circumference of this circle being approximately 15.7 centimeters. Okay? So let's move into some application problems that you may see dealing with perimeter and circumference, and they aren't going to necessarily be straightforward, such as what is the perimeter of this figure. Lots of times you're going to need to work backwards, so they'll give you the perimeter or they'll give you the area or the surface area or something, and you'll need to find one of the measurements. And that's what's happening here in this first example. A square has a perimeter of 36 inches. What's the length of each side? Well, if I think about a square, all the sides are congruent, so all the sides are the same. So if this is S and this is S and this is S and this is S, how many S's would make up the perimeter? I would do S plus S plus S plus S, or 4S equals the perimeter. So that's the formula that I want to use here. 4S, 4 times the side, is going to give me 36. So I simply divide each side by 4. So the side length is going to be 9 inches. The second problem says that we have a rectangle with a perimeter of 60 inches. The width is 3 times bigger than the length. What is the width of the rectangle? So in any type of geometry problem, your best first step is to draw a picture. So here I've got my rectangle, and the width is 3 times bigger than the length. So let's say the length is x. The width is 3 times that, so 3 times x. My drawing is not to scale. So in a rectangle, if this side is x, this side also has to be x. And if this side is 3x, this side has to be 3x. So how am I going to find the perimeter? I know the perimeter is 60, so I know that all of these sides added together need to equal 60. So I'm going to write my number sentence, x plus 3x plus 3x, and that's going to give me 60. So then I combine like terms. 3, 6, 7, 8x is 60. So then I divide both sides by 8, and I end up with x being 7.5. So 7.5. X, remember, was the length of the rectangle. The problem, however, asks me for the width of the rectangle. So if the length is 7.5, the width is 3 times that. So 3 times 7.5, and that's going to give me 22.5 inches. Don't forget your measurement. So the width is 22.5 inches. The next problem says we have a circle with a circumference of approximately 47.1, let's just call this units. What is the diameter? Okay, so remember with circumference we have two options. We have 2 pi r or we have pi times d. Since the problem is asking me for diameter, I'm going to use the pi d formula. So I know that the circumference is 47.1. So all I need to do is divide both sides by pi, which again we're approximating pi as being 3.14. And when I do 47.1 divided by 3.14, I end up with a diameter of 15 units. So these are the area formulas that you have to memorize, and you're going to have quiz after quiz after quiz on these until you have them and you're reciting them in your sleep. The area of a square is side squared. Okay, side times side is side squared. The area of a parallelogram, and a parallelogram is any figure that has two parallel sides. This includes a rectangle. So that's going to be base times the height. And anytime you see height in a formula, it always has to intersect at a right angle. So I couldn't use a slanted side here as my height. It has to be perpendicular, has to intersect at right angles with one of the bases. Okay, so the area of a parallelogram is base times height. In a triangle, it's 1/2 base times height. Remember, again, height has to come from a vertex and be perpendicular. I can't use one of the slanted sides of the triangle. The area of a circle is pi times the radius squared. Can't use the diameter, it has to be radius squared. And then the area of a trapezoid, which is the height times the top base plus the bottom base, and the bases are always the parallel sides, never the slanted sides. So base 1 plus base 2 divided by 2, or 1/2 height, base 1 plus base 2. So these are ones that you're going to have to memorize, and you just absolutely have to know. So let's see them in application problems. The area of a circle is approximately 78.5 centimeters squared. What is the length of the diameter? Well, I know I'm dealing with area of a circle, so I know I'm using area is pi r squared. Okay, it gives me the area 78.5. That is equal to pi times the radius squared. The diameter, well, I need to find the radius first to be able to find that diameter. So, my first step is to divide both sides by pi. Remember that pi is 3.14. So, when I divide 78.5 by pi, I end up with 25. So 25 equals the radius squared. How do I solve for something that's squared? How do I undo that? I do the square root of both sides. So 5 equals the radius. This will be an answer choice on your test. However, it is not the correct answer choice because the problem asks for the diameter. So once you find the radius, be sure that you know exactly what the problem is asking you. If my radius is 5, my diameter is twice that, so the diameter is 10 centimeters. Okay? So here we have a trapezoid that is 48 inches squared. So it's the area. The height is 6, and one of the bases is 7. What is the length of the other base? Well, I need to know my area formula for a trapezoid, which is 1/2 times the height, and then add the two bases together. And then I fill in what I know. I know the area is 48. I know the height is 6. I also know one of the bases is 7, and I'm going to use x to be the other base. Alright, so I need to simplify what I can. 48 equals, I'm going to go ahead and do 1/2 times 6, or 6 divided by 2, that's 3. 7 plus x. Okay, I have two options from here. I can either distribute and then divide and subtract, or I can go ahead, since this term is in parentheses, I can go ahead and divide both sides by 3. So if I do that, I end up with 16 equals 7 plus x. Then to solve for x, subtract 7. So 9 is x. So the missing side, the missing base, is 9 centimeters. Right here, a triangle has an area of 12.5 centimeters squared and a height of 5 centimeters. What is the measure of the base? Again, it wants you to work backwards. Area of a triangle is 1/2 base times height. So I know 12.5. That's equal to 1/2 the base, which I don't know, and the height. The height is 5, and the base we're going to call x. Alright, let's go ahead and multiply both sides by 2. Let's get rid of that fraction. So I end up with 25 equals, the 1/2 and the 2 go away, 5x divided by 5, so x equals 5. So the base of the triangle is 5 centimeters. So here's a more in-depth problem, but it's still really easy. A square has an area of 289 millimeters squared. Second square has an area of 169 millimeters squared. What is the difference of the side lengths of the two squares? Well, to answer this, I first need to know what the side length of each square is. So, I know that the area of a square is the side squared. So if a square has an area of 289, that's equal to the side squared. I can do the square root of both sides, and I end up with 17 is one of the side lengths, 17 millimeters. Then I would do the exact same thing on the second square. 169 is side squared, square root both sides, and 13 is the side. So what is the difference between these two? 17 minus 13, 4 millimeters is the difference in side length. So it just wanted a couple of extra steps. It added a second square, and it wanted you to find the difference of the side lengths. So now we're going to move into surface area, and really there's not much of a shortcut for surface area. You're going to do exactly what it says. You're going to find the area of all the surfaces, and then you add it together. The only one of them that you do want a shortcut for is a cube, because a cube is made up of squares, and it's made up of 6 squares. So I've got the area of each square is going to be the same. It's going to be side times side, and I've got 6 of those. So the surface area of the cube is 6 times side squared. The cylinder is also a special case because it's got circles. And anytime we have circles, circles have to be different, so we have to throw in that measurement of pi. Okay? So to deconstruct a cylinder, it's easy to see that we're going to have 2 circular bases. The curved surface is what kind of throws people off, but really that curved surface is simply a rectangle. If you take a piece of paper and you roll it in half, it makes that tube shape. That is all that curved surface of a cylinder is really a rectangle. So a cylinder is really made up of 2 circles and a rectangle. So I know how to find the area of the 2 circles. The area of one circle is pi r squared. So if I've got 2 of them, I just multiply that by 2. So I have 2 times pi r squared. That comes into play here. The second part's a little bit more tricky. If you think about, let's go back here, the height of this cylinder is really just the width of this rectangle, right? So if I call this H, it's still H in the cylinder, okay? It's the height. If I think about this side of my rectangle, this is what is really forming the outside of my circle. And remember, we have a formula for how to find the outside of a circle. It's the formula for the circumference of a circle. And that is going to be 2 pi r. 2 times pi times r. So that's this length. It's the outside of the circle. This is the height of the cylinder. So if I wanted to find the area of this flat surface, I'm just multiplying 2 times pi times the radius times the height. So my formula then becomes 2 pi r squared, just the circles, and then 2 pi rh, that's the rectangle. And that's a formula that you just have to memorize. 2 pi r squared plus 2 pi rh. The sphere is also a special case because it has no flat sides, but the sphere is really easy. You just take the area of a circle, pi r squared, and you times it by 4. So the surface area of a sphere is 4 pi r squared. That's another one you just have to memorize. So let's find the surface area. Here we have a rectangular prism with a width of 3, height of 5, and a length of 7. Alright, we're looking for surface area. So here's my prism. Alright, it's got a width of 3, a height of 5, and a length of 7. So, how many faces does this prism have? It's got 1, 2, 3, 4, 5, 6. A top and a bottom, 2 sides, and a front and a back. So let's find the area of each one of those. So first I want to talk about this back side here. So I'm looking here. It's going to be a rectangle with 7 times 5. Okay, that's the sides of that rectangle. So I'm going to do 7 times 5, which is 35. But I have 2 of these sides, right? So I need to multiply this measurement by 2. So 70. Alright, let's look at the bottom here. The bottom is 3 by 7. Okay, this long side is 7, so 3 times 7. And that is 21. But again, I've got a bottom and top. So I need to multiply that by 2. I end up with 42. And lastly, I have the front, which is 3 times 5, which is 15. But I have a front and a back, so I multiply it by 2, and this gives me 30. So the surface area is the sum of all these, so I end up with 142 inches is my surface area. I should say inches squared. Surface area deals with squares. Alright, cylinder has a height of 10 and a diameter of 4. This is one where we just have to know the formula. Formula for cylinder, the surface area is, it's 2 parts, the 2 circles, 2 pi r squared, and we add that to the rectangle, 2 pi r h. So, all I'm doing is filling in r and h. So 2 times pi, which we're using 3.14, times my radius. If my diameter is 4, the radius is 2. Okay? Be sure you're paying attention. So 2 squared plus 2 times pi times 2 times 10. If you plug that into your calculator, you'll end up with 150.12. That's going to be centimeters squared. Okay? Now for a triangular prism. Okay? We have two triangular bases, 1, 2. So I need to know the area of this triangle. The base of the triangle here is the same as the base on this side, so it's 3, and the height is 4. So I have 1/2 4 times 3, which is 1/2 times 12, which is 6. But I have 2 of these faces, so I multiply that by 2. Now I need to look at the rectangular faces. So let's look at the bottom here. It's 8 by 3. It's a rectangle that's made up of 8 by 3. So I do 8 times 3. That's the area of this rectangle, which is 24 centimeters. Now I have to look at this face. Still has a length of 8, except now the width here, notice that it's marked congruent with this side, so this side is also 4.3. So I have 8 times 4.3. And that is going to give me about 34.4. Okay? But this pink side is the same as this pink side on the other side of the triangle. So I multiply this by 2. And I end up with about 68.8 centimeters. So now I have all the measurements. I have 1, 2, 3, 4, 5 faces. Good. So then I add this together, and I end up with approximately 104.8 centimeters squared. Okay? So find the diameter of a sphere with a surface area of 452.16. Again, you just have to know your area formula. Your surface area is 4 times the area of a circle. Okay? So I know my surface area, 452.16, is 4 times pi times the radius squared. Let's divide both sides by 4 and by pi. You can do this each in different steps if you want to, but if I divide 452.16 and then on my calculator I type divide by 4 and then divide by pi, we'll do them both at the same time, and it will give me 36 is r squared. So to find the radius, square root both sides. The radius is 6. However, the problem asks me for the diameter. If the radius is 6, the diameter is twice that, so 12 centimeters is the diameter. Then we have the length, the side length of a cube with a surface area of 294 inches squared. Remember, we said that the surface area of a cube was 6 times the side squared. So, 294 is equal to 6 times the side squared. Divide both sides by 6. I end up with 49 equals the side squared. Let's take the square root. So the length of the side is 7, so 7 inches. Okay? And lastly, I want to look at one that's kind of an EOG favorite, and it has to do with cylinders. So a company makes canned soup. Most of the time cans are cylindrical in shape, so we're going to be dealing with a cylinder here. The soup cans have a diameter of 2 inches and are 6 inches high. Label paper costs 0.005 cents per square inch. About how much will it cost to make labels for 1,200 cans of soup? Alright, so we know soup comes in cylindrical cans. So if we're talking about wrapping a label on the outside of this can, we're only talking about this part, right? The flat surface. Because soups and aluminum cans and things like that, they never have anything on the top or on the bottom. It's only this flat surface. So when I'm dealing with that surface area formula, surface area is 2 times pi r squared plus 2 times pi times the radius times the height. Remember, this part dealt with covering up these two circles. Well, if I'm looking at the label on a soup can, I don't care about those because I don't have a label on that part. I'm only going to deal with the rectangular face of the cylinder. So in soup label problems or labels on some other kind of cylindrical thing, it's only going to deal with the rectangle part. So you forget the first part of the cylinder formula. So my radius, the diameter is 2, so the radius is 1, and the height is 6. So I plug this into my formula, 2 pi times the radius times the height, and that gives me 37.68 inches square. Okay, that's for one soup can. So if this label is 0.005 per square inch, I multiply this by 0.005. And that gives me approximately 0.19. So about 19 cents per can. However, I'm looking at 1,200 cans. So I take this 0.19 and I multiply it by 1,200. And I end up with approximately $228 to make my soup label cans for 1,200 cans. Alright, so you need to practice on memorizing these formulas. You are going to have a quiz on all of them, both two-dimensional, so area of squares, rectangles, all that stuff, and the three-dimensional, cylinders, cubes, surface area of prisms and things such as that.